Hello, welcome. My name is Shia Nafti. In the next few minutes, I'm going to take you through the process of installing Moodle. Moodle is an e-learning open source project. We're going to install Moodle on the Google Cloud platform using Google Kubernetes Engine. We're going to start off by enabling APIs to services on the Google Cloud platform, which we're going to use during this session. Next, we're going to create the network for our Kubernetes cluster and Moodle application. Having created the custom mode network, we're going to proceed and create a subnet for this network in the US Central 1 region. In the next step, we're going to create the IP peering range. Let's create a private connection to our CloudSQL instance using the peering IP range and our private network. With the network configured, let's move over to step number 3 and configure our database. We're going to start off by creating a database instance. Having created the database instance, we're going to create a cloud storage bucket for our backups. Next, we're going to enable versioning on our cloud storage bucket. Having enabled versioning, we're going to create a lifecycle policy to delete backups after 30 days. Let's apply the lifecycle policy on the cloud storage bucket. Let's enable administrative access from our Cloud Shell console to the CloudSQL instance. Let's create a user for our Moodle database in the CloudSQL instance. Having created the user, let's create a database for Moodle in this instance. Having completed the administrative tasks, let's disconnect from the network. Before moving on to step number 4, where we're going to create a Kubernetes cluster for our application, let's visit the Google Cloud Web Console and explore the tasks we've just performed. We're going to start off by exploring our networking configuration. You can see the network we created previously. The network was created as a custom mode network. We subsequently created one subnet. The subnet was Moodle-subnet in the US Central 1 region. We allocated an IP address range to this subnet. Let's move on to our CloudSQL configuration. The CloudSQL configuration is under the storage section. This is the database instance. It's a MySQL database instance. It's a private database. On the main dashboard, you can also view the connection name for the instance. Let's click on the instance to explore further. On the overview page, you can see a dashboard and some additional configuration information on the database instance. Let's move on to the Connections tab. In the Connections tab, we have confirmation of the connectivity. This is a private connection. If you scroll down, you can view additional configuration information. Let's have a look at the users. Here we have confirmation of our Moodle database user, which we created previously. Let's explore databases. You can see here the Moodle database. This was created in step number 2. Let's explore backups. Currently, we don't have any backups. However, we configured automated backups when creating the database instance and specified a 4-hour window for backups. Let's return to our Cloud Shell console and carry on with the next step, step number 4, during which we're going to create a Kubernetes cluster. Let's ensure we are working against the right project. Let's set the zone for our Kubernetes cluster. Let's create a 1-node Kubernetes cluster in the US Central 1A zone. Having created our Kubernetes cluster, we're going to retrieve its credentials. Next, we're going to grant admin privileges to the current logged-in user. Let's create a service account for Tiller, which we're going to need in order to install a number of additional components into the cluster. Let's grant Tiller admin privileges against the cluster. Let's initialize Helm using the Tiller service account. Let's create a custom node pool for our Kubernetes cluster with auto-scaling enabled. Having created the custom pool, let's cordon off the existing workloads on the default pool. Let's drain workloads from the nodes in the default pool. Let's delete the default pool. With the default pool deleted, we now have all of the workloads running on nodes within our custom pool. Let's move on to step number 5 and configure the certificate manager. We're going to start off by adding the Helm repository for the certificate manager application. Let's update our repository's cache. Let's create a namespace for our certificate manager application. Let's label this namespace disabling validation. Let's create custom resource definitions for our certificate manager application. Let's configure the cluster issuer for our cert manager using the staging configuration for Let's Encrypt. Let's deploy our certificate manager application into the cert manager namespace using the Let's Encrypt staging configuration. Having configured our certificate manager, let's proceed to the next step, step number 6, where we're going to configure our Ingress controller. Let's start off by creating a regional IP address in the US Central 1 region for our Ingress controller application. Let's set the external static IP address created as an environment variable for the load balancer IP. Let's create a namespace for the Nginx Ingress controller application. Let's install the Nginx Ingress controller application in the Nginx Ingress namespace using the environment variable for the external static IP address allocated. Having installed the cert manager as well as the Nginx Ingress controller, let's return to the Google Cloud Web Console and explore our Kubernetes cluster as well as the deployed applications. From the landing page of the Google Cloud Platform Web Console, let's navigate to the Compute section, select Kubernetes Engine and Clusters. We can see here the Moodle cluster. It's located in the US Central 1A zone. Currently has 3 nodes, and you can see the resources allocated to those 3 nodes. Let's select the cluster. On the Details tab, we can view additional configuration information on the cluster. And at the bottom of the page, we have configuration for the node pool. Let's select the Nodes tab. Under the Nodes tab, we can see high-level configuration information on the 3 virtual machines that represent the nodes within the cluster. Let's move on to the Workloads tab. Under the Workloads tab, we can see the workloads that have been deployed into the cluster. There are 2 namespaces. We have a namespace for Cert Manager along with the Cert Manager deployments. We also have a namespace Nginx Ingress, and here you can see the deployments for the Nginx controller application. Let's navigate to Services and Ingress. Under Services and Ingress, we've got 2 cluster IP services for the Cert Manager, as well as 2 services for the Ingress controller, one of the type load balancer, and the other service of the type cluster IP. Let's navigate to the Configurations tab. You can see here the configuration for secrets for our Cert Manager, as well as Ingress controller, and 1 config map for our Nginx Ingress controller application. Let's return to our Cloud Shell console and proceed with the next step, where we're going to build the Docker image for our Moodle application. Let's select step number 7 to build the Docker image for our Moodle application. We're going to build a Docker image using a Docker file in the project directory. Let's configure Docker to use gcloud as a credential helper. Let's tag the image for Google Container Registry. Let's push the image into Google Container Registry. Let's proceed to step number 8 and configure the storage class for our Moodle application. Let's define our daily snapshot schedule. Let's create a persistent disk for shared Moodle application data. Let's create a Kubernetes storage class for our Moodle application using the SSD persistent disk type. Let's proceed to step number 9 and configure our Moodle service accounts and secrets. Let's create a CloudSQL service account for our Moodle application. Let's set the unique email address of our service account as an environment variable. Let's assign the role of CloudSQL client to our Moodle CloudSQL service account. Let's download the key for the Moodle CloudSQL service account. Let's create a namespace for our Moodle application. Create a Kubernetes generic secret in order to grant access to the Moodle CloudSQL key from within a Kubernetes cluster. Let's create an additional generic secret in order to enable access to the database credentials, that is the username and password, from within the Kubernetes cluster. Let's move on to step number 10, where we're going to configure a network file system for accessing shared data on the persistent disk we configured earlier. Let's configure a 10 GB persistent volume for our NFS service. Let's configure a persistent volume claim requesting 10 GB of storage space using the access mode of read-write many. Let's configure our NFS service. Having configured our NFS service, we're going to configure our NFS deployment. Let's return to our Google Cloud Web Console and explore the configuration we've just performed. Let's start off by exploring the image we created and pushed to the Google Cloud Container repository. To do that, we're going to navigate to the Tools section and select Container Registry. Under the Images tab, we can see here our Moodle image. Here we have the unique ID for the image, the version as a tag. Let's navigate to the Compute section. Select Compute Engine and Disks. You can see here the disk that was created for our Moodle application data. The disk is an SSD persistent disk of 10 GB. We configured a snapshot schedule. Let's have a look at the disk's configuration. Here we have confirmation of the disk type, the size, and the zone, as well as the schedule. This is the snapshot schedule we configured earlier. Let's navigate to the Compute section. Select Kubernetes Engine and Clusters. Let's click on the Moodle cluster and select Storage. Here you can see the configuration for our storage class. Let's click on Moodle Storage Class. This is the configuration. You can also view the YAML file for the storage class. The storage class is of the type Persistent Disk SSD. The zone is US Central 1A. Let's return to the Storage tab. We can also see here the configuration for our persistent volume, as well as our persistent volume claim. Let's have a look at the configuration of our persistent volume. Here we can see the YAML file for our persistent volume. The persistent volume access mode is read-write many. Storage capacity is 10 gigabytes. And you can see the claim reference. Let's return to our Nodes tab. And let's select the configuration for our persistent volume claim. This is our persistent volume claim, making a claim against this volume, this persistent volume. We can view the configuration as a YAML file. Let's proceed to the Workloads tab. Under the Workloads tab, you can see the deployment for our NFS server. The deployment is in the Moodle namespace. This is the namespace where the Moodle application will be deployed. Let's have a look at services and Ingress. You can also see the NFS service in the Moodle namespace. This service is of the type cluster IP. Let's navigate to the Configuration tab. Under the Configuration tab, we can view the secrets we created. The CloudSQL database credential secret enables access to the username and password of the database from within the cluster. The CloudSQL instance credentials secret enables access to the JSON key for the CloudSQL service account from within the cluster. Let's return to our Google Cloud Shell console in order to proceed with the deployment of our Moodle application. In step number 11, we're going to deploy our Moodle application into the Kubernetes cluster. Let's start off by configuring the service for our default HTTP backend. Let's configure the deployment for our default HTTP backend. In the next step, we're going to configure a config map in order to enable the Moodle application to have access to a number of key environment variables. Having configured the config map, we're now going to create the service for the Moodle application. With the service configured, we're going to create a deployment for our Moodle application. In the next step, step number 12, we're going to configure the final resource, an Ingress. An Ingress allows us to configure access by external users to the Moodle application. Let's change the service type of our default HTTP backend from a cluster IP to a node port service. Let's convert our Moodle service from a cluster IP type to node port. Let's create a global IP address for accessing our Moodle application. Let's configure our Ingress using a custom domain based on the global IP address using the xip.io service. Let's explore the application configuration on the Google Cloud Platform. Let's navigate to Workloads. Under Workloads, you can now see our Moodle application deployment. Let's navigate to Services and Ingress. Let's sort by namespace. In the Moodle namespace, we have the backend service as well as the Moodle application service, the front-end service for 2 pods that are running. We also have the Ingress configuration. Let's click on the Ingress configuration. Under the configuration, we can see a number of annotations. We also have here the TLS secret as well as the load balancer IP. The endpoint is based on a custom domain. Let's click on this endpoint in order to access our Moodle application. Let's select the advanced option and confirm that we wish to proceed. And after a few seconds, we have access to our Moodle application. This concludes this session. Thanks for watching and have a nice day.